Hey, welcome back to your favorite pre-calc class. This is section 2.1 functions. We're going to talk about what a function is, find the value of a function, the difference quotient of a function, talk about domain range, and some operations. So let's start with determining whether a relation represents a function. First of all, you can have a relation with anything. Like here's a relation, if you will, a relationship between x and y, x being your input, y being your output, and they drew the line. So you can have a relation mathematically with a line. You can have a relation between states and the number of representatives that those states have. You can have a relation between persons and their phone numbers. You can have a relation between animal and life expectancy. But not all relations are functions. A function is a relation that associates for each element x there's exactly one element of y. So what I always remember is because people like to think in terms of x and y. For every x, there is one y. So for every x, there's one y. For every input, there is one output. For every element x, there's one y. So let's go back to these first examples here showing the mapping. So you want to say for every x, x being our domain, y being our range here. So for every x, there's one y. For every x, there's one y. For this 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 x, there is one y. This is a function. Let's go to this one. For this x, there's one y. For this x, there's one y. For this x, though, you notice there are two y's. This is not a function. Okay, so you notice if you've got an x that's got a couple different y's, again, not a function. The saying is for every x, there's got to be one y. Here we got a function. For every x, one y. For every x, one y, and so on. There is a function there. That is a function. So here's some other relations here. We'll state the domain and range and determine whether it's a function or not. So your domain here is your calories. So your domain would be 580, 650, 541, 550, 700. Your range here would be your fat. So 31, 37, 33, 29, and 43. It's that set, okay? Now, is it a function? Sure, for this x, there's one y. For this x, there's one y. For this x, there's one y, and so on. For every x, there's one y. So that is a function. Here your domain are each of these, your range are each of those, and let's check it. For this x, there's one y. For this x, one y. For this x, one y. For this x, one y. That is a function. Let's go to figure 8 now. For this x, there's one y. For this x, though, notice there are two y's. This one is not a function. Okay. Now, what if it's in ordered pair? Well, if it's an ordered pair, you could still do the mapping if you wanted to. You know, you have that 1 that's going to 4, you have a 2 that's going to 5, you have a 3 going to 6, a 4 going to 7. So you notice that, yes, this is a function. Or you can just leave it as an ordered pair. B also, 1 goes to 4, 2 goes to 4, 3 goes to 5, and 6 goes to 10. So yes, B is also a function. Erase these real quick, and now let's do C here. So C, we have negative 3 going to 9, negative 2 going to 4, 0 going to 0, 1 going to 1, and you have negative 3 also going to 8. So because of that negative 3 problem child, this is not a function. So notice if I'm looking at it as an ordered pair, anytime I've got that repeated x, that same x going to different y's, not going to be a function. All right, is a circle a function? This was the old unit circle, so we had the origin was at 0, 0. HK here was 0, 0. Okay, so right there in the middle was our HK, and our radius r squared was 1, so we had a radius of 1. So here's my circle. Ugh. Now, for each x, is there one y? Well, let's pick an x of, let's say, a half here. If I look at an x of a half, well, at a half, you notice there's a point up here, there's a y up here, and there's a y right down here as well. Okay, so it is not a function. And one way you can do that, and we'll talk about this also in the next section, is you can run what's called the vertical line test. The vertical line test tests if whether it's a function. It can only hit once. You can only hit once to be a function. So you notice on a circle, when you run any vertical line at any point in the graph, if you ever have it hitting more than once, it's not going to be a function. Okay, so here's a graph. Let's say you were testing this. And you say, well, I only hit once here, that's fine, but then any other point that I try on this graph, notice I'm hitting twice, so this one also is not a function. Whereas like a quadratic only hits once, so a quadratic is a function. Okay, so the vertical line test tells you whether you have a function. Now, if you're looking at this from an algebraic standpoint, if you have x squared plus y squared equals 1 and you solve this thing for y, so you have y squared equals 1 minus x squared. Notice when you solve this thing, see that plus minus right there? That's going to tell you when I plug an x in, it's going to spit me out two y values. Y equals a positive and a negative of whatever. So this thing's not going to be a function. So the giveaway is, algebraically, if you have an even power of y, it's not going to be a function. Okay, even power y, not a function. Now let's work with some function notation here. If you remember, f of x is simply a nickname. This is just a nickname for y. And it's just to make things shorter and more concise in mathematics for mathematicians to work with. So if you're given f of x equals 2x squared minus 3x, f of x is saying find y, or I'm sorry, f of 3, we're plugging, f of 3 is telling us find the functional value, in other words, find y, which is f of x, the functional value when x is 3. You can just say find f of 3. Well, so you just plug 3 in for x. You got 2 times 3 squared is 9, so you got 18 minus 3 times 3 is 9, so you got 9. F of 3 is 9. In other words, when your x is 3, your y is 9. F of 3 equals 9. Oops. Alright, let's do this part B now. It says find f of x plus f of 3. Well, f of x plus f of 3, so now your f of x, you take that 2x squared minus 3x, and you add in f of 3, and if you remember, we had f of 3 was 9. So it's f of x plus f of 3, there's f of x plus f of 3. So these are all different ways of just looking at your function notation on this thing. Okay. I'm having trouble with this eraser, aren't I? That thing around. Alright, let's do a couple more here. Let's do this 3f of x. That just says take 3, multiply by f of x. What's f of x? 2x squared minus 3x. And you just multiply that. Okay. Let's do f of negative x. Here's your f of x. Plug in negative x. And you've got 2x squared plus 3x. What is the difference between that and negative f of x? Well, negative f of x means negative, and then you put in your f of x, which h is 2x squared minus 3x. And you distribute that. See the difference there? Let's do f of 3x now. F of 3x. Now we're just going to throw in 3x for x. Well, we've got 2 times 9x squared minus 9x. We've got 18x squared minus 9x. And there's f of 3x. And finally, f of x plus 3. F of x plus 3 now. F of x plus 3. So now x plus 3 goes in for x. So we get x plus 3 quantity squared. Don't forget that is quantity squared means you got 2 of those. So I'm going to go ahead and FOIL that. X squared plus 3x plus 3x. I'm going to combine those. That gives me 6x. And then finally plus 9 on the end. I distribute that now. So I got 2x squared plus 12x plus 18 minus 3x minus 9. So we got 2x squared. I got 12x minus 3x. Combine those. So we got 9x. 18 minus 9. I got a plus 9 on the end. So there's f of x plus 3. Alright, finding the difference quotient. This is a kind of a lead-in into calculus and limits, derivatives, that stuff. So it's a foundational for a derivative. But all they want us to do is find a difference quotient in a pre-calculus class. So you're going to use that little f of x plus h minus f of x all over h, and you're just going to simplify it for this. So let's go ahead and write f of x. Let's write the difference quotient. This is what the difference quotient is. Okay. And I'm going to go to the side and I'm going to do that first. So I'm going to take my f of x. I'm going to find f of x plus h first. So 2x plus h squared minus 3x plus h. So I've got 2x plus h. I got 2 of these x plus h's. Distribute that minus 3x minus 3h. So I got x squared plus xh plus hx. That's the same thing. So I have 2 of those xh's. And then plus h squared on the end. Let me distribute my 2 through, so I got 2x squared plus 4xh plus h squared minus 3x minus 3h. Okay, and that's what goes in right here. That's my f of x plus h. So I have 2x squared plus 4xh plus h squared minus 3x minus 3, whoops, that's supposed to be h right there, 3h, minus, and now I got a minus my f of x right here, my original function. So I got too much in the way here. So I minus my original function, which is 2x squared minus 3x. This is all over h. Okay, I'm going to go ahead and distribute that. So you notice I have 2x squared plus 4xh plus h squared minus 3x minus 3h minus 2x squared plus 3x all over h. 2x squared minus 2x squared, gone. Minus 3x plus 3x, gone. So it looks like I'm left with h. I'm going to write h squared first. and I also have 4xh, and I have a minus 3h, 4xh, and this is all over h. And if I can, I'm going to factor an h out of each of those, which each of them does have an h in them. So h is left minus 3 plus 4x. This is all over h. And I do that so I can simplify and cancel out that h. So I'm left with my difference quotient simplifying to that right there. H minus 3 plus 4x. That's my difference quotient. Alright, let's talk about our domain here. The domain of a function, when you're starting out talking about domains in pre-calc, we're going to assume it's all real numbers, and then we're going to look for problems. Okay, in other words, can I put in any x that I want? The domain is a set of all real numbers. So if you look at x squared plus 5x, you say, well, I can throw in any x that I want, and it'll always spit out a y. So my domain for that is all real numbers. So the domain would be from negative infinity to positive infinity. It can be all real numbers. You can also say that in set notation, x, such that x is an element of all real numbers. This is element of all reals. I mean, so we have no restrictions. X can be anything. You know, if you were looking at the graph, I don't know exactly what it looks like. We'll say kind of like this, right? X squared plus 5x. You notice there's no holes, jumps, gaps in this thing. It just keeps going to the left. So it can be any x value. If I pick negative 5, it's on the graph. Negative 6 is on the graph. Negative 3 is on the graph. Any x that I pick is going to have a corresponding y. So x is all real numbers. Okay. Whereas the second one, if you're looking at it, notice you have a denominator, x squared minus 4. Okay, if I have a denominator, you got to consider that thing. And if it can be factored, factor it. Okay. And you notice, remember, I cannot divide by 0. So I can't have a 2 here, because 2 minus 2 would be 0, and 0 times that, 2 plus 2 would be 4. 0 times 4 is 0, so I would have a 0 on the bottom. Okay, I also cannot have a negative 2 right here, because negative 2 plus 2 would be 0. So I'm creating a 0 on the bottom. Again, I cannot divide by 0. So I got to throw out 2 and negative 2. So my domain would be all reals except for it cannot be negative 2 or 2. Okay, if you want to put that in interval notation, that's coming from negative infinity up to negative 2. Do not include it, so we have a parenthesis because we're not including it if you remember interval notation. And then from negative 2 up to 2, do not include that 2 either. And then from 2 to positive infinity, and we keep going on that. There's your domain for part B. Now for the third one there, you notice that you have a square root. Okay. So anytime you've got a square root, just think to yourself, well, I can only take the square root of 0 or positive numbers. I cannot take the square root of a negative number in the real numbers anyways. Okay. So if you're finding the domain involving a radical, take the radicand, whatever's underneath, excuse me, and you say all that stuff underneath has got to be greater than or equal to 0. This is what t can be. Right? We're working with t here instead of x. So you solve for t, so I subtract 4 from both sides. Divide by negative 3. Don't forget that when you divide by a negative, you got to flip that inequality. So this is what t can be. T can be less than or equal to 4/3. In other words, the graph of this thing is going to look something like that. It's going to be less than or equal to 4/3. So it's coming from negative infinity up to 4/3, and we can include that or equal to 4/3. This is our domain on this. Okay? The way you say that in set notation is t such that t is less than or equal to 4/3. Okay? Now part D, you take that, you say that 3x plus 12 has got to be greater than or equal to 0. You solve that. So x has got to be greater than or equal to -4. And you also notice I got to throw 5 out because of the denominator there. So x cannot be 5 as well. And that's your domain on that. Greater than or equal to -4 cannot be 5. Alright. Now lastly, our function operations. So make sure you write these down. This is your addition, subtraction, product, and quotient operations with functions. So this f plus g just means take f of x, add g of x. F minus g, take f of x minus g of x, and so on. Let's do an example here. So if f of x is 1 over x plus 2, g of x is x over x minus 1, f plus g of x would just be take your f of x and add g of x. That's all that means. So if you notice right here, here's my f of x, I add in g of x, I get a common denominator, and we move on. F minus g of x is f of x minus g of x. You got your f of x here minus g of x, get a common denominator, work with that. If you go back to the original question here, now we're going to take the product, f times g of x, and then we'll do f of x over g of x. So here's f of x times g of x. Multiply your numerators, multiply your denominators, and finally f of x over g of x. When you divide by that fraction there, that rational portion there, you want to keep, change, flip. All right, and that's how you're going to divide by that x over x minus 1 there. That's your operations. Thanks for watching. See you guys soon.